Amalia, why was 6 afraid of 7?
Because 7, 8, 9. My kids told me that one already. Awesome.
Yeah, it's good dad joke.
Absolutely. Just like pointing out the hay. Did you try that one yet?
I haven't had a chance. We don't have a lot of hay in Portland.
We got so much right now in Wisconsin. It's everywhere.
Okay, I've got 2 after, so pretty good with just going ahead and starting. So thanks everyone for joining. I'm Mitch Horry, Focus on Energy Performance Manager at the PSC. We are here for the final presentation for the energy efficiency and rooftop solar PV potential studies. These studies have been, well, the energy efficiency potential study kicked off back in May of 2020 and just wrapped up last month. And then the solar PV potential study kicked off in May of 2021 and just wrapped up this week. I do want to give Commissioner Huebner, who's on the meeting, an opportunity to say a few words here at the beginning. So, Commissioner, if you're ready, go ahead.
Great. Thank you so much for having me, Mitch. And again, just wanted to take a moment to thank our team here at the Public Service Commission, led by Mitch, the Cadmus team, and everybody listed on the top of this presentation deck, and then also all of our stakeholders here in Wisconsin for your participation and efforts to help guide and instruct this process. And we're very excited to have the updated potential study. We did get a briefing. The 3 commissioners here this morning got a briefing from Cadmus and the team and Mitch on the results, and looking forward to this briefing as well. But again, thank you for your participation. It really strengthens our Focus on Energy program, and it strengthens our energy efficiency and renewables efforts throughout Wisconsin. And we look forward to continuing to engage with you as the quadrennial plan process unfolds over the next few months. So back to you, Mitch. Thanks again for having me.
Great. Thank you, Commissioner. I couldn't have said it better myself. Thanks to everybody for joining. And let's just jump right in if you can. So next slide, please. Just on the top here, I won't take very long. Same kind of format has been done throughout all these stakeholder meetings and presentations. If you could please just make sure you're on mute to avoid any background noise, and no need for anyone to be on video at this time, and the presenter can turn on video if they'd like. There will be times throughout the presentation where we'll stop for question and answer. If you would like to enter a question into the chat at any time, that's certainly welcome too. Next slide, please. So as I mentioned, this presentation is going to cover both the energy efficiency and solar PV potential studies. Realize that some folks may not have been engaged in both of these studies. Many of you have, and so you'll get a look at the results from both of those studies here in this presentation. Talk about the results and conclusions for each, and we'll close with next steps in terms of what to expect for Focus on Energy quadrennial planning process, and then with a final discussion and Q&A. So that's my portion of this opening series of slides, and I'll send it over to Steve at Cadmus to present on the energy efficiency study.
Great. Thanks, Mitch. I'm Steve Kofer, principal at Cadmus, and involved in the focus evaluation and help support the potential study. For those who have been participating in these for the last 5 sessions, Lakin Garth was leading those, and I am not Lakin, so that's probably apparent, but I will be stepping through the next set of slides here. And we just wanted to kind of start off with, just like we usually do, kind of resetting what the objectives were for the study. We wanted to assess the statewide potential across the 12-year timeframe and do some exploration and modeling around some different scenarios, looking at different potential opportunities as we change cost-effective tests, include different benefits, and those are discussed throughout the report. We do not cover program potential, so this is at a portfolio level. These savings are gross savings; they're not net, and we'll talk through a little bit about that in the coming slides. And this is potential studies intended to help provide act as a data source for informing the quad planning. So it is not intended to set the quad goals. It's intended to be one source of many to help inform the planning process and the goal setting. And from the beginning, we set out to incorporate feedback from this group and others to ensure that we're aligned, we're speaking the same language, and the guidance that we received in the feedback, I think really helped shape the overall and final product of the potential study. So thank you very much for those who contributed with comments and participating in the past stakeholder meetings. Here's the timeline, and we've made it to the end. We're at the end. This is the last presentation. The reports all have been posted onto the Focus on Energy website and can be downloaded there. It's been a little over a year. We're all a year older. And so, again, thanks for hanging with us. I always think it's good to kind of go back to this slide to make sure that we're talking the same language and we all understand what goes into the different levels of the potential estimates. So at the top, we have technical potential. So that's everything that is theoretically the maximum energy efficiency potential. So it does not take into account any constraints around costs, other market barriers. If a widget can be turned into an energy efficiency widget, it's done so in that modeling. Economic is a subset of the technical, and economic is applying a screen, economic test screen, to only include measures that are cost effective. So we use the modified total resource cost test, which is the approved Focus on Energy test. And then as a subset of economic, we have optimized, and optimize is not controlling for any funding levels or controlling where that funding goes by sector or fuel type. It does include some maximum achievable limits as well as some ramp rates, but it's not constrained by funding or where that funding goes. And then under current policy, we do constrain the funding levels and where those funding levels go based on policy and or what has been historically used in the program. So that's the different levels of potential that we estimated in this report. And I think I mentioned before, we're not providing any program targets that will be established within the quad planning. The next couple slides take us through high-level results of the electric and the natural gas potential. So in the upper left-hand corner, we have the different levels of energy efficiency potential from technical down to current policy. And then we also are showing what that potential is as a percent of baseline sales. As you'd expect, as you start to put more limits and constraints on the different levels of potential, you have less opportunity. The percent of baseline sales for the electric side is similar to what we saw in the 2017 study, which was the last study that Focus on Energy conducted. The upper right corner is showing the percent of electric optimized potential. And so this is showing optimized potential at the sector level. Residential, industrial have some of the largest shares on the electric side. Again, that aligns fairly well with what we saw in 2017, as well as what we've historically seen from the program. And then the bottom figure is the electric energy efficiency potential as a percent of sales annualized. And the dark blue bar at the bottom is 2019 program savings. What those are gross savings. Those are not net savings. And then what 2019 saw as a percent of sales. And you can see that it's relatively close to the current policy model as well. On the natural gas side, we saw a similar trend. If you look in the upper left-hand corner, one thing to note about the natural gas is that we did use lower avoided costs between the last study and when this study was conducted. The avoided costs have been updated and they are lower. We'll talk a little bit more about that in some subsequent slides and what impacts that had. But on the natural gas side, it definitely drove the efficiency opportunities lower. And that was largely due to the avoided costs. On the sector level, we look at the upper right corner, the natural gas optimized potential. Residential showed that it had the highest level of potential out of the different sectors. Again, that was largely contributed to the lower avoided costs. On the commercial and government side, those natural gas measures that were somewhat on the margin in the last study were no longer cost effective. And then the last graph on the bottom, again, is showing percent of sales annualized and compared to the 2019 program savings. So I'm going to step through quickly some conclusions on the residential electric and non-residential and then the gas savings. One of the big drivers for one of the big things that we saw in this study was around LED lighting on the residential side. Looking back to the last study, it's about a 50% decrease, and that's largely contributed to a couple different reasons. One is the federal policy is changing, so there are federal policies being put in place, and so forecasting those out, there's fewer opportunities in the future. And then the market has matured rapidly. The quality of LEDs is quite high. People seem to be very satisfied with them, and the cost has been driven down to a comparable, slightly above what a halogen is, but it's been driven down quite considerably to a comparable level to non-efficient technology. And then finally, the FOCUS program has been incentivizing efficient lighting from CFLs then to LEDs for a very long time and has seen great success with that. And with that great success comes limited opportunity for future energy savings. We are seeing, this study showed a few emerging opportunities, such as heat pump water heaters. They weren't cost effective in the last study. This study, they are proving to be cost effective. Central air conditioners, high efficiency central air conditioners are another example. and there's multiple examples that are outlined in the report. So that's, I think, where the program can start to look to see if any of those are viable program options. And the other piece that is probably notable is to kind of fill that gap between those residential lighting savings, since they're going to be starting to go away over the course of the next few years. Probably need to look at some new program design changes, or maybe emphasis on programs that are successful that could scale a bit larger to help kind of close that gap. On the residential gas side, we saw high potential in low-cost widgets, such as like low-flow shower heads, aerators. Those are still showing pretty good opportunity on the residential side. We did see good opportunity also with the residential natural gas furnaces. Maybe just to put a finer point on the gas furnace piece too is Focus has had a long history of implementing, incentivizing natural gas furnaces, been very successful in helping change that market. And so I just want to kind of point out that the potential study is, as I mentioned before, gross savings. And so we aren't accounting for any program attribution, market effects, free ridership, spillover. And so we're not, the report doesn't kind of note that, but I think it's an important piece for all of us to know that it's not necessarily indicating go out and do increase the incentives for natural gas furnaces. It's really just a data source for us that there's still opportunity at least at the gross level, and potentially program opportunity as well. And then what we saw with the increased funding level, so one of the different scenarios that we ran was increasing the funding by 50% and by 100%. And when we did that, the natural gas measures responded pretty well as far as showing a lot more opportunity. And that's the result of that is really driven by removing those constraints that the current policy has. And the current policy has constraints around funding caps, but it also has some constraints around where that funding goes by sector and by fuel type. And when we remove that, we saw good responsiveness from the natural gas measures. And I don't think I have it on as a slide, but the electric savings did increase, as you would expect, as you put more money in, but it's not as pronounced. On the non-residential side of things, as I mentioned before, the avoided costs had an impact, specifically on the commercial and the government side. If we look from the 2017 report to the 2021 report, the lower avoided cost is driving the opportunity and the potential in that sector. And similar to the increased funding, natural gas showed a pretty good change when we ran through different scenarios of using different cost effectiveness tests, or when we lowered the threshold for what measures need to pass. So going from a 1.0 to a 0.75 or a 0.5 cost effectiveness threshold, we saw some large increases in measures that now become cost effective. And I think that's a point that kind of saw throughout this study, is that those natural gas measures are kind of borderline depending on the sector, and are relatively sensitive to benefits that are added or removed. On the non-residential electric side of things, still a lot of opportunity with screw-based lighting, looking at 34% of the total lighting potential. Even with the increased level of LEDs, there's been a lot of movement in the commercial industrial area with LED technology, but there still is a good amount of opportunity. Commercial refrigeration also showed a high level of refrigeration, or high level of opportunity. And then on the industrial sector, 99% of the industrial technical potential is cost effective. And then we also saw in the industrial sector, process measures accounted for really the largest share of the economic potential in that sector. And I'll just note that the process measures increase in energy efficiency potential is largely contributed to adding in new information to this study than the previous study. So some of the feedback that we received from stakeholders in 2017 was some advice and guidance around how to approach process improvements in the industrial sector. And so we met with several of you this study and have applied a couple different ways of approaching that. We had quite a bit of stakeholder feedback, so thank you. We hosted 6 different engagements. We sent the report out for comment and received 113 different comments from 5 different organizations and or individuals. And then we also had a large contribution of market experts helping with the ramp rates and assigning those to the different technologies. So thank you for those who participated in that. That was very helpful. That was a change in the design this year, where the previous potential study we used a willingness to pay, and based on feedback from this group, it was decided to change that, and we included some participation around how to apply those ramp rates. Major kind of changes to the study. The last study used achievable potential. This time we're using optimized, so it's a naming convention, but it's also, as I just mentioned, a method change as well. And we changed how we estimated the optimized potential. From this study and the feedback from this group, we ended up conducting a rooftop solar potential that we'll be talking through here momentarily. And then we had quite a few changes to the report itself based on the feedback that we received. So we reorganized how we were presenting the income qualified findings. We added some more additional detail, emphasized things differently based on feedback, and just had quite a few different edits, and we really appreciated that feedback. So that's what we have today on the energy efficiency potential. Happy to take questions. And you can put your questions in a form of a comment if that's preferable as well. We'll have an opportunity to ask questions later. So if there are no questions, then I think we can just move to the solar study.
Well, you guys certainly are quiet today. Hopefully you're just gathering up some thoughts for conversation at the end. Hello, my name is Amalia Hicks, and I'm also a principal at Cadmus, and I helped lead the rooftop solar PV potential study. I am located right here in Madison in our nice cloudy rainy day. Oh, okay, so I think you can move ahead, Steve, please. Okay, so the rooftop solar PV potential study objectives were to assess technical rooftop solar potential. And I just will mention here that we did not cover ground-based solar in this study. That was not inside of the scope and would have involved a lot more effort than probably could be done in the short amount of time that we had to complete this study. So it's just rooftop solar. Our objective was also then to simulate market adoption potential, and we did that using the NREL designed and supported DGEN tool. Also through that tool, we looked at a couple of different economic scenarios and modeled those to see how they might affect a solar rooftop PV adoption under alternative policy conditions. And we also conducted a side review of literature and also interviewed some stakeholders from that are running successful low-income solar programs to talk about and investigate what kinds of barriers there are in that market and ways that those successful the folks that run those successful programs have found to help offset some of those barriers. And of course, one of the objectives is to just have some more information to provide to stakeholders in the commission as we head into the Quad 4 program planning period. And finally, of course, it was our objective to, make sure that this study was that stakeholders had a voice and were able to, get back to us with feedback and help guide the study as it moved along. So you can see the timeline there. It was pretty condensed. We started it in the spring and had, maybe 6-ish months to complete it. So we're at the end today. Next slide, please. So as I mentioned a little bit before, we used the DGEN model that is supported by NREL. This model calculates technical potential they use satellite imagery to determine how much rooftop area there is that's oriented in the right direction to be able to adopt solar. That's the technical potential. And then through economic modeling and some assumptions, some of which you helped us dial in to be realistic, such as the price of the technology and how quickly it declines over time, et cetera, that the model takes those economic parameters and calculates or simulates the market adoption potential of solar rooftop PV. Next slide. So if we just look at technical potential, this is not shocking. It's intuitive that it basically follows the rooftops. So where you can put rooftop solar, there is where the technical potential is highest. So if we just put solar panels on every available roof in Wisconsin, the technical potential is 3 times larger than the current capacity in Wisconsin. That because of the fact that solar happens at different times of day, not at night, more in the summer translates into an actual electric energy production of about 70% of the statewide production. Wisconsin imports some of its electricity, and so if you just looked at the overall consumption in Wisconsin in 2020, the technical potential would cover about 65% of the energy consumed in Wisconsin. Another caveat is that, you know, one of the limitations of this study is that, oh, sorry, somebody have a question? No? Okay, I'll keep going for the moment. One of the limitations of this study, again, due to the constrained timeline and scope, is that we are not looking at the technical potential does not account for the limitations of the grid or any upgrades that would be necessary to, you know, for the state to be able to adopt this much solar as the technical potential. It's really just, you know, the cap that we're using as a comparison point to see how much of that will actually be adopted or is simulated to potentially be able to be adopted under the different scenarios and inputs that we used. Were there any questions on that before I move on? I wasn't sure if somebody just accidentally went off mute. Okay, there'll be time at the end too. So let's see, this slide has a lot on it, but when we ran the models, the total simulated market adoption potential is less than or around 2% of the total technical potential by 2034. And most of that simulated market adoption potential is in the residential sector. 23% is in income qualified sector, and then commercial makes up 30% of the market adoption potential that came out of the DGEN model. And this chart you can see on the left here breaks it up into IOUs, and then other contains co-ops and municipal utilities. And in 2020, we calibrated it to start out at you know, what we could find on data gathered about the existing, you know, current adoption. And then from that point, the model simulated using economic scenarios and inputs how that adoption would increase out until 2034. The model uses these things called agents, which effectively are, they represent a statistical amount of the population, and those agents then choose whether or not to get to install solar panels based on the different conditions in the model. And the main driver of adoption is payback timescale. So as it becomes more financially possible and advantageous for folks to adopt solar, then more of these agents adopt it. Next slide, please. Okay, so we ran a baseline case using existing conditions in Wisconsin for simulated market adoption potential. We also ran 4 additional scenarios to investigate how things might change if these different scenarios took place. So one of them was a net metering scenario. And I should mention that some of the Wisconsin utilities currently have net metering policies and some do not. So in the net metering scenario that we ran, all of the utilities in the simulation had net metering policies with a 500 kilowatt maximum capacity cap. And when you turn on net metering in the DGEN model, it's kind of a switch that you flip in your inputs. The kind of baseline net metering type that it selects when you do that is the kind where, say, a customer makes 100 kilowatt hours in a month, but they only use 80 kilowatt hours. Those 20 in excess production get rolled over as credits into the next month. And that then continues on until 12 months. So it's trued up at a year. So anything, and the model, I should also say the model, the way that NREL built it, it currently constrains the size of solar arrays to equal the amount of energy use of that household. So, so anything that was produced over what the household used would get set back to zero under this net metering scenario. However, at least on the residential side, because of the constraint that it can only be big enough to use to create the same amount that the household uses, it would basically go to zero anyway at that point. Another scenario that we looked at was increased focus on energy incentives. I probably don't need to read through every detail here because you can all read, but it raised the maximum incentives and also the amount per watt for standard income qualified, and also commercial customers in the program. The third scenario that we ran was more attractive financing, where we dropped a down payment to nothing and reduced the interest rate of the loan. And then finally, our final scenario was to extend the federal income tax credit for another 3 years, essentially. And we ran all of these on both the residential scenario, residential simulation and commercial. Next slide, please. So here are the results, and you can see, well, you can see immediately that the net metering scenario really has the most influence and produces the greatest simulated increase in potential, 34% by 2034. The red dotted line is the baseline. And then increased focus incentives create a 6% increase in simulated market adoption potential. Extending the tax credit is also a 6% increase. And attractive financing has a little bit more influence. That increases the simulated adoption by 8%. Next slide. Are there any questions so far? I just want to stop and make sure. Good, okay. Oh, Kathy. Kathy is still confused about why the market potential increases so much more for other. Okay, so solar or electric rates did have a big influence on the simulated market potential. But I don't know, do we want to go back to that slide? It's a couple, it's like one more. There we go. So Kathy's question is about the other, which is that top blue. So there are a couple of, I think, main reasons that other increases quickly. And then there are some more like super weedy things. So just to kind of stay at a high level, I think the kind of zeroth order influences of that were that it starts out, you know, one of the things that affects like overall simulated adoption is where you start. So the starting point on other is actually pretty high. There's already a significant amount of solar installed in that area. So the starting out point matters, but then also that one there's net metering policies in place in the simulation for other. So we know from our scenarios that the net metering is the biggest influencer of the rate of growth in the simulation. So that also had a fairly sizable effect. I don't know, Jeremy, if there's anything else you want to add to that, or I did justice to that answer.
Yeah, I would also mention, oh, I have an echo.
I can't hear your echo.
Sorry. Another factor is the size of the market that the technology can diffuse into, and other being the non-IOUs is a very significantly sized residential market, and the residential adoption rate is particularly strong compared to commercial.
Yeah. Does that help at all, Kathy?
Yes, thanks. That does.
Thank you so much. Okay. Yep. Alrighty. Anything else immediate? Okay. So if we break it down by building type, we've already covered kind of that, and Jeremy just mentioned it again, that residential single-family homes offer the greatest opportunity for adoption of rooftop solar. That is broken out into 68% of those are single family and 4% manufactured homes. On the commercial side, there is the largest contributors are retail, warehouses, and offices. And then a smaller contribution for multifamily, which has some, that comes into some of the considerations around barriers, at least when you look at it from the income qualified perspective, which is probably coming up soon too. Roll the slides, please. Okay, this graph is a little bit challenging to explain, but the takeaway is that that gray shaded area represents the current focus on energy peak period, which is summer weekdays, but non-holiday between 1 and 4. And the lines, the green one shows shows solar production, generation capacity. And it's the way both of those lines are shown, if you added up all the percentages, it would add up to 100%. So it's really just showing you, when does the peak generation occur compared to other times of the day. And so obviously solar is going to really happen, peak at the middle of the day. The blue line is a average peak day in the summer load for the state of Wisconsin. Now, what's confusing about this graph a little bit to me is that we calibrated them this way so that you could see them together. If you calibrated the total load compared to the contribution of solar, it's much higher. So this really is just designed to show you that that a lot of the solar generation happens during the peak period, 42%, so that it could contribute somewhat to reducing the peak load, but overall, the simulated adoption would decrease it by about 3%, I think, in our calculation. So that blue line, I know it looks like it's doesn't really peak, but I think that's because the solar peaks so strongly during the day. And if you change the y-axis and, so that it really only takes the maximum and minimum of that line, you would actually see that there is a peak in the middle of the day on our Wisconsin load as well. Okay, so we, as I said, just talked with stakeholders in the income qualified space and did a literature review to ascertain the main barriers to solar PV adoption by income qualified customers. These homes, again, represent 23% of the simulated adoption potential, but there are some significant barriers that, I'm sure many of you are familiar with. We've focused on the three largest barriers. One is, of course, the cost burden. And then the stakeholders that we interviewed talked about approaches that they've seen or that they've taken that have ameliorated those barriers somewhat. And so on the cost burden side, that would be replacing loans with grants or incentives that don't have to be paid back, flexible incentives so that income qualified customers could receive higher incentives, and third-party ownership, which currently is not legal in Wisconsin, but in other states they have seen that as a possible solution to some of that cost burden. Another big barrier is home readiness. Sometimes the income qualified housing maybe doesn't have a new or stable roof to mount the solar array on, or there could be other issues, electric panels, etc. So potential solutions on that front are to couple your solar program with grants or incentives for repairs, or to try to leverage existing energy efficiency programs. Focus on Energy already has a home performance program that could maybe be used in concert with a solar PV program, but helping the homeowners repair anything that needs to be repaired prior to installing solar is, kind of the main solution for that one. The third barrier is multifamily challenges. So if the stakeholders that we talked to suggested if you also have incentives for property owners, that can help lift that barrier a little bit. Also, standardizing net metering or virtual net metering, which is kind of like a community solar where the multifamily residents would, buy in portions of a larger array and they would each get some benefits from that. Okay, so like the energy efficiency potential study, we've been really grateful for stakeholder feedback and the opportunity to meet with you guys. And you've really improved these projects and outcomes. We've had 3 meetings. We've tried to welcome outside, emails outside of those meetings and discussions. We did get 49 comments on the draft report from 6 different organizations. And so we did take your feedback and what's the word I'm looking for? I'm just going to stick with feedback to heart. We used it to come to consensus and finalize the different modeling inputs. such as financing assumptions. We dialed in and confirmed the economic scenarios using stakeholder input. And then we did make a couple of kind of major changes to the report. We added some language on cost effectiveness because that it can be kind of weedy. So we tried to elaborate on that a little bit and take it to, introduce it better. We put in context on ground-mounted solar. A number of folks were, I think, a little saddened that that couldn't be part of the scope this time around, and we tried to make that clear that it was not. The granularity of population growth estimates is a study limitation that we tried to add some text on as well. And then we also added more detail about the specific type of net metering that was simulated by the DGEN model. Okay, so ask away. And definitely feel free to go back to Steve's portion so I can take a sip of water. Anyone? Questions? Mike? It seems that the energy efficiency studies have been refined over the years, but there has been less opportunity to refine the solar PV study. What are some lessons learned or other improvements that could potentially be made for a future solar PV study? Would it be possible to look at things like community solar potential? Would you use the DGEN software or some other tool for future studies? That's a lot. Okay. So there could definitely be refinements, and I might leave the lessons learned a little bit to Jeremy, but it kind of depends on the scope and the timing a little bit, because again, like it was constrained this time, and this is the first one that's been done in a while. So, so I think it would be, possible next time to, I mean, could we look at community solar? That's an interesting question. I mean, the things like ground-mounted solar get to be complicated because you need to think about how they're going to connect to the grid. And so the potential, for example, of where you can put a ground-mounted solar array is more complex than basically just counting roofs where you probably already have an electric connection. Jeremy, do you have any lessons learned that might be worth mentioning?
Well, we noted several limitations in the study that I think would be interesting to address in future studies. So the DGEN model is an extremely powerful program, and it's also open source. And so there is, for future studies, there would be an opportunity potentially to do more reprogramming on the model itself to address limitations like further constraints around low-income adoption that we essentially for this study were a little bit creative with the inputs that we could manipulate, but maybe some further reprogramming could allow us to get to get the estimates closer to the multitude of constraints that were identified throughout the study. Other things that I think would be interesting to look at were more dynamic population shifts that I think could be addressed with potentially programming the model. But yeah, I think it's a really powerful tool. We did learn more about the limitations, but they are ones that for future studies could be addressed with more time and more reprogramming effort. And we've had a really great dialogue with NREL throughout this whole process, and have been feeding them, a lot of the observations that stakeholders have also made to us about what would be interesting to look at. So certainly some really interesting lessons learned. I think there's some limitations that we've talked about that would be hard to address with a model like this, and that's ground-mounted solar, because this model really relies on measuring rooftops and not considering open space and proximity to distribution lines and all those kinds of factors that I think you would consider for ground-mounted. I'm not sure that's a limitation that could really be addressed with DGEN. I think that would require a different type of model. But yeah, overall, it's been very interesting, and like I said, it's an extremely powerful tool.
Thanks, Jeremy. So Jolene also posted that by statute, Focus can't fund community solar, only customers cited. And then it looks like Commissioner Huebner has his hand up. Did you want to say something?
Well, it's a big topic, and I wanted to ask about heat pumps for, heating as a heating system. I know fuel switching is a sensitive topic around focus on energy and whether that piece, but mainly I'm thinking about homes that are already electric resistance or other sort of electric heat, and kind of where did heat pumps fall in as far as cost effectiveness, but then also estimates of market adoption for that technology. Thanks.
That one's on Steve, I think. You're muted. Sorry.
That probably helps. As you noted, yeah, the fuel switching was not a component of the EE potential study. So the way that it was treated as if it was a natural gas furnace, the efficiency measure would be a high efficiency furnace, or if it was electric resistance, it could move up to higher efficiency, say heat pumps. As far as what we saw, I might have to defer to one of my colleagues, Sophia or Aquila, in regards to what the potential was for shifting from baseboards to heat pumps in this particular study. So I guess before I speculate on what I think it says, Aquila, do you have any insight into that?
Hi, I would have to look at that specific case when we're talking about electric baseboard applications going to heat pump technology. That was included as part of our study. We, in those types of applications, what we're talking about are ductless heat pumps. And there are savings opportunities, especially for that type of application. The savings can be pretty notable on a site level basis. The main thing that is notable though is that type of application is just replacing electric resistance heating, and through our surveys and through our collection, primary data collection efforts, the electric resistance, the population that has electric resistance heating is relatively small compared to natural gas heating. And so while there are opportunities on the heat pump side, and we did model that, we didn't look at any sort of electrification potential, but yeah. So while there is heat pump potential, and in the case that I'm referring to, Sophia can probably correct me if I'm wrong, but I believe it was cost effective for baseboard heating going to ductless systems. But again, the saturation of those that have baseboard heating is relatively low compared to the population in the state. Now that does change by segment. Multifamily would have higher electric resistance, so there could be higher opportunities in multifamily compared to single family, for example. So there could be some targeted approaches there.
And then Steve, I think this kind of maybe dovetails a little bit with a question from Kathy about approaches or more emphasis on electrification studies or electrification in general, or how a study could address electrification.
Yeah, so on the energy efficiency side of things, I think that we saw as we ran through different scenarios, those scenarios created different levels of costs and benefits. And what it didn't do, though, is if we're looking at it from an electrification standpoint, there's reasons beyond saving a kilowatt or a therm around electrification. It's more around saving carbon, reducing emissions, and the current cost tests that we've been using don't necessarily always account for the benefits maybe in an appropriate way when we're looking at electrification. And so I think from that lens, I'm not sure there's a lot to draw on like insights from this study, how it would impact conversations about carbon goals or emphasis on electrification. I think we might be able to tease out some meaningful insights, but from a larger macro level, I'm not sure it really provides a lot of data sources because of the different objectives between saving energy versus saving carbon. And I don't know, Molly, if you have any insight at anything on the solar potential.
In terms of electrification, I mean, the simulated adoption was small enough that I'm not sure it would have, I mean, it certainly would reduce carbon for sure. But along with, Steve's comment, when we looked at, for example, cost effectiveness of solar panels, solar rooftop PV, it was around 1 for the modified TRC, and that's currently the focus on energy primary cost effectiveness test. So kind of to echo Steve, if Wisconsin had, through some of, the governor's goals, decided to adjust that primary cost effectiveness test to something that included more of the carbon reduction benefits, then it would be, at least on the potential study side, the measures that reduce carbon and energy use would rise higher in the kind of hierarchy of measures with higher impact.
Yeah, and I'll just maybe round that out too by saying that I wouldn't be comfortable saying that this document should be used to help kind of develop those roadmaps for focus. I think it does provide a good foundation to work from if those conversations move in a meaningful way, and you know, focus on energy, the commission is interested in understanding what that might look like. I think that these two studies are really a lot of the legwork has been done to kind of move forward and to look with the roadmap, you know, with that lens, that different lens than energy efficiency. So I do think it's some foundational work that would need to have happened regardless.
And I think Mitch had some slides too about kind of how this ties into quad planning. I wonder if he would be a good one to, like, maybe we should let him move on to those, because that seems like it's kind of where the conversation is going.
We do have
Let me
one more.
just please address the last question, and it's if industrial, the industrial sector was part of the rooftop study, and the answer is no. Industrial facilities were not part of this study. And warehouses, yes, they are part of the commercial sector.
So before we move on to kind of closing out the presentation here with Mitch, I'm going to step through some next steps. Is there any other comments or questions? Okay. Mitch, it's all you.
Okay. Thank you, Amalia and Steve, and thanks for the great questions, everyone. Yeah, these last few slides are just to kind of let the group know what to expect when it comes to the next steps for quad planning. You know, a way I like to think about the potential study is it's kind of the beginning of the process where we've got this great foundational information, some of which is going to be really useful, and some of which we're just going to have to think about from these broader topics that have emerged, because Kathy mentioned that the commission has indicated are in scope for the next quad of focus. Broadly looking at a high level, the timeline here shows kind of what to expect in terms of the quad planning process. But if you could go to the next slide, happy to show some more detail, because this includes some more immediate opportunities for stakeholders to provide their comments formally on the record in the quad planning docket, which is 5 FE 104. So if we go down this activity list and approximate time period here, we see that October 7th today, that's the presentation of the final study results and what staff are expecting next to happen and following past processes would be a memo out for public comment that's seeking input on the scope of Quad 4. So for the 4-year period of focus on energy beginning in 2023 through 2026, what topics rise to the top that the commission needs to consider in its decision making? That's an opportunity that stakeholders have to provide that input, and we're anticipating that to come toward the end of this month. So if you're subscribed to the 5 FE 104 docket, you can expect to see that notice and request for comments coming relatively soon. And we're anticipating a 3-week comment period. So that's a great opportunity to provide your input if you've been along for this study and have particular comments and issues that maybe you've expressed through this study stakeholder engagement process that you'd like to raise on the record in 5 FE 104. It's a good opportunity to do that. And so that scope memo and the comment periods followed by decisions from the commission on what is and what is not in scope for Quad 4. That sends a signal to staff. These are the things that we need to come back and get more analysis on to put those issues before the commission, to give them policy alternatives for consideration. Now, since there are some new areas that we're that are in scope for Quad 4 as determined by the Commission in the carbon roadmap docket, carbon-free roadmap docket. We see this approach as likely needing to have kind of a high-level policy decision-making period first, where we get some direction from the Commission on what those topics mean to them, what the direction for those particular topics might be, and that will really help shape further decisions in the quad planning docket, those that are kind of dependent on those decisions and directions. So what we're envisioning is a two-step process. You can expect, we've got tentatively scheduled for March and May next year, where there will be the decision alternatives and discussion and analysis in front of the Commission. So those are, again, separate opportunities along the way for stakeholders to provide comments and input. And wrapping it up, we are hoping to get through those series of memos and discussions in the summer, and that would leave a period of time for a program to gear up for the next Quad of Focus, which would start January 1st, 2023. And so that's kind of a more detailed process of what to expect for quad planning, and happy to take any questions here on this process or how stakeholders can get involved. And again, there the docket number 5FE104. When you subscribe to that docket through the Commission website, you'll be sure to get all the notices by email when there are opportunities for stakeholder engagement and comment. Well, I do want to take a moment just to say thanks once again to everyone. This has been a great study, great process. Really enjoyed all the opportunities to hear from you all, and I think it was said earlier, but definitely a better study came out of it through that stakeholder process. So I just want to make sure I once again said thank you very much. As always, we're available for questions even after the fact. So there's the potential study website, and that's got all the resources along the way, including recordings of all the presentations, the slides. So please access those if you're interested in going back and seeing what was done.
Yeah, I'll just reiterate what we've said from Cadmus. Thank you very much for all the feedback. I certainly believe the product, the potential study, both of them benefited considerably from the feedback from this group. It's really nice to be able to discuss ideas along the way as the studies are being developed, then after the fact. That's always a nice way to approach this. So appreciate everyone's time and effort on this. And with that, are there any other questions or anything? Otherwise, I think we can conclude a little bit early. All right. Well, thanks, everyone. Hope you have a good rest of your week.
Thank you.
Bye, everybody.
Bye.